Very much. Hi, everybody. I'm here to talk about ICS monitoring. So actually, I should have been the surprise number one and Daniela surprise number two, because we're going back to basics. We're going to talk about the hardware and the software and how to actually gain monitoring and visibility in the ICS. Because, spoiler alert, there's not much happening. So this is the topic of the session. Who am I? I work in industrial security. I'm Dominika Rusek Jonkers. I started working at Secura exactly a month ago. And 2 days ago, my colleague called me, asking, hey, yo, can you fill in for this, speaker slot on Friday at VCon? Which I said, yeah, sure, why not? So bear with me if there are any mistakes or, things exploding on the PowerPoint. It's been a long 2 days. So before I joined Secura, I worked at Deloitte, cyber branch, basically. And I focus on industrial security. So I did a lot of pen testing, offensive type of work, hacking. I didn't actually do the afsluitdijk. I didn't do that one, but many other things, chocolate factories, metros, and manufacturing plants. And then I realized it's super fun to break things. I love it. I still do it. But I also like to help clients to, get better at things, right? Because there's usually a bunch of things that you should be improved. And that's how I got into the realm of monitoring and also network segmentation, because I like to just help them, improve the status quo. And as you can see, ICS industrial work can bring you into many fun places, not always super ergonomic. You might be sitting somewhere in a super weird, awkward position for a week. So let's dive into that. But before we go into monitoring, I want to talk to you about the ICS. What is it actually? And I like to think of it as a foundation of our modern society, basically, because you can find the ICS systems everywhere. In the power plant, right? Energy grid, generation, transmission lines, in the mining sector, in the manufacturing, from medicine to your food to, things like chocolate, which is, a critical sector, if you ask me. So everywhere in our world, we have the ICS systems, and that's what we're going to be talking about today. And this is a little bit of the visual representation, just to give you a heads up. Usually there is a physical process. So that's, for example, a hydro dam in this case. So it produces energy. And then that energy is transmitted into the businesses and our homes. So we can watch Netflix in the evening, right? On a Sunday. And so this physical process is actually controlled by industrial control system, right? So ICS, that's where the little computers are, like programmable logic controllers, or the graphical interface of those, so the operators can see what's happening, which is the human-machine interface, for instance. So these type of systems are there. And of course, there is an IT corporate LAN as well. Hopefully there is a firewall between two, but we'll get to that. Sometimes it's flat, sometimes you actually have some sort of firewalling. And that's basically the usual system, as I call it, right? Servers, workstations, so things like SAP, for instance, for ordering systems and these sort of things. So there is a bit of a difference, not a bit actually, it's huge. A huge differences between the IT and ICS. And I'll get to that because it's important to understand that before we start talking about monitoring these industrial systems. So on the left side, you can see the regular IT environment. We're all used to that. Banking, consulting, right? Workstations, data centers. Similar protocols, right? No matter if you're in a banking institution or a consulting system or a consulting company, you're gonna have HTTPS, right? You're gonna have SMB, you're gonna have LDAP, you're gonna have Active Directories. Well, on the ICS side of things, that can be quite drastically different. And this is the type of things we see in industrial systems. Sensors, actuators, measuring temperature, measuring quality levels, right? There are PLCs, as I mentioned, so the type of little computers which are ruggedized, but also robotic arms in a production line, right? Assembling things, for instance. And the protocols, for instance, that can be vastly different between the sector and even from one manufacturing to another manufacturing plant. There are different estimations. Some are saying there's 250 plus different ICS protocols. And the regular security systems, security monitoring systems won't be able to parse that because they don't understand it, right? So you need specialized tooling to actually cover this. And actually, some are already open source, like Modbus, for instance. It's just standardized. Some are proprietary, the protocols, and some are created by a Joe 30 years ago, right? That wrote a program to just in protocol to interface between the devices. And now he's retired, and now I have to reverse engineer it if I want to understand it, right? So completely different environments, and it's important to keep in mind when we go into the monitoring. And there's one more important concept in the industrial realm, which is the Purdue model, which is the IEC 62443 ISA standard, golden standard of a network, if you will, basically. In IT, we have the Aussie model. In ICS, we have the Purdue model. And basically, it's the ideal status quo of a network. Not always the case, I can tell you. Very often there are not so many layers with security in between. Let me see if I can find the laser. Yes, we start with the level 0, which is the physical processes. That's basically the sensors, actuators, the physical process. And then we have the level 1, which is right about here. And these are the PLCs or RTUs, so the devices that actually control that physical process. And then we go a level higher up, level 2, which is the area supervisory control. That's where the operators would look at the graphical interfaces, for instance, or the HMIs, human-machine interfaces, to see if everything is okay, and happening in the production, basically. And then we have the level 3. And here you can find things like engineering workstation. And that's a regular laptop, you could say, actually, that actually downloads a program file, project file onto a PLC, for instance, right? So they should be able to communicate back to the PLCs to send the code there. And then the red boundaries is a planned DMZ. And that's something we really want, right? Because we don't want the IT directly connecting into the industrial network. So that's where you would have things like maybe Historian, which is actually just a database, which sends the data about the production results into IT so that the enterprise systems like SAP can pull that data, right? And of course, above is the enterprise network and internet, so the usual systems that Daniela was talking about. And we assume that the monitoring is there. That doesn't bother us, right? It's probably there. So now that we know what industrial is, what are the limitations, why do we need specific tooling for ICS, let's dive into the monitoring a bit. The industrial industry is a couple of years behind. I remember even throughout my career, a couple of years back, I would have conversations with the clients, trying to argue why they should invest in monitoring, because there was no visibility into what's happening on those lower layers of the Purdue model. They really had no clue. And I had to really be creative in saying, okay, but you want the asset visibility. You want to see what's coming, right? And if something happens, you want to be able to analyze the logs. And already the conversation has shifted actually to discussions that we're having right now, which is, okay, no, I know I need it, but how can you implement that, right? How can we make that happen? And that's what I want to briefly discuss today. But of course, if we really want to go into details, we would be here until Sunday. So there's a lot of things here going on. So basically, I won't be focusing on the specific monitoring solutions because there are many. Clarity, Nozomi, there is ForScout and Dragos, of course. But it's just semantics, if you ask me. If anybody is from here, from the companies, don't come to me complaining. But I really think it's just a matter of, okay, choose a tool. If you're fine with it, it's how we actually implement it. How do we gain the visibility? That's important, right? Not the software that we actually use. So let's talk about the deployment strategy. We have a chocolate factory, because it's critical, right? And we have no visibility in the lower levels of the Purdue model. We have a Splunk happening in the enterprise system and that's fine. That's all being monitored. But we have no clue what's happening on our production line. So how do we go about something like this? Well, first of all, we need to understand the network, right? Because we need to talk to like operators, plant managers as well. You need to make best friends with the engineers, network engineers, because they need to be on your side and they have a lot of information that potentially is not documented. Or they find a way, maybe an Excel spreadsheet which is lying around somewhere and you can find the asset essentially. So really, just check the existing documentation. It's not going to be up to date. Absolutely not. But at least it's a starting point. And then you go on the site. You actually go visit the chocolate factory and you look, okay, what kind of switches do I see in the cabinets? How many PLCs are in there, right? I need to understand how it's actually the production plant is being organized, right? There are different stages in the production as well. So you just need to sort of visually inspect things as well. I remember times where I was at the customer site and there was the switch I identified. It was nowhere to be found. Not in the asset inventories. People had no clue what that was. So I was literally looking at the cables. Okay, what does it connect to, right? Where does the Ethernet cable go to? And then we updated the asset inventory, and then we sort of then deployed the monitoring. So, you can be a bit of a detective as well in that respect. You're not gonna be 100%, you're not gonna gain 100% visibility right away. It's simply not possible because there's gonna be network segments which you can't access, basically. It's the vendor deployed and, they just hand it over and they manage it. You can't change network configuration. You can't create a span port. I'm going to get to that later. So simply not possible to gain visibility. And of course, there could be other cases, right, where you need to tweak and tune later on in the process. But in general, those are the first things. Critical assets, you want to understand them. Because we're talking about ICS, availability is very important. So we need to know that our monitoring solution doesn't actually introduce any changes to the network, doesn't threat that availability. We identify critical network segments. That's also important. The choke points, which are basically intended bottlenecks on the network. For example, a remote access jump server, that would be such a choke point, so that this traffic needs to go through that jump server, right? So you want to be monitoring that. You also want to identify the ICS hotspots. So that's basically where a lot of operations occur. For instance, engineering workstation is an interesting one to tap, right? Because that's going to be sending and downloading the project files onto the PLC, effectively changing the production. There are a couple of network data collection methods that we're talking about when we're talking about monitoring. The golden standard is the passive. That has been there for years, basically, which essentially means passively listening to the network, connecting to a span port or creating an RSPAN, and basically just listening to whatever is flowing on the network, right? Of course, it has limitations because some devices might not be talking, proactively, or they might not be talking for, let's say, half a year because, there is a special production schema, right? So it's silent. And if you're only capturing for 2 months, then you're not going to see that device, right? But it is the safest way of gaining visibility because you're not introducing any new traffic into the network, which is great. So the industry basically was always relying on the passive, but however, in the last couple of years, there's more of an active approach as well, in combination with passive approach, which means that you're querying and pulling for data. So you're requesting data. But don't think about stuff like Nestus or Nmap. We're not scanning the network. Absolutely not, because, that can trip the devices and actually shut down your production. Operators will not be happy. You're going to be smacked by the plant manager. No, just don't. Here we're talking about solutions like Nozomi, Clarity, and such, mimicking the actual network, right? Traffic. For instance, engineering workstation, the example I gave before, is going to use certain, WMI, for example, or is going to use S7COM communication to download the project file so that basically in the active querying polling mechanism, they're going to try to mimic that, essentially. Needs to be done with care, though, and I noticed that some clients or some industries are very afraid of that, and maybe it's better to try on the least critical network segment first, before you actually gain trust of the operators, and they're like, okay, you can do that in the main one as well. And another thing is an AppDB, so basically you ingest and parse backup files or configuration files of the PLCs, right? Where would you use that? For example, if the network is air-gapped, and you cannot create a connection because you don't want to introduce new setup, right? You don't want to introduce new cabling. Or, for example, it's very remote, somewhere in the desert, right? And it's really totally isolated. That's what you could do, basically. Every once in a while, pull the configuration file, upload it into the tool, monitoring tool, and at least you have visibility into what's happening, like the registry values, right? Of the PLC, for instance. So there are different, data collection methods, and the best way is to use all three of them in some degree. You really have to figure out what is available and what is, should be used for the network. And if we're talking about monitoring, it's not just the software, it's also the hardware, right? Because we're talking about sensors, network sensors. It's gonna be Intel NUCs or Asus NUCs or whatever, just NUCs, so local computers that you can plug into a switch, into a span port. You can also do like a one-use or unit data server rack, basically. That's the example that I have here is from Nozomi. So the software vendors also provide hardware if you want to, but you can also just deploy it yourself. But there's also, Ethernet cables, fiber. You might need to have the connectors, Ethernet to USB or fiber to USB, right? SFP modules, if the switches need those actually to communicate back to the NUCs. So it's important to also figure out, okay, what kind of switches do we have in the factory? Are they managed? If they're not managed, then you're not going to be able to create a span. Then you need to tap, right? So this is all also needs to be pulled into consideration. And now to the sensor deployment. I have a little example. So here is the network, let's say of a chocolate factory, right? And then you have 4 different production lines, basically, different parts of the process. And basically the core switch and above, that's IT. So that's not out of our interest, basically. So where do we want to plug in the sensors or the servers? What is the configuration, right? What should we do? So here's an example. This is, not vendor related. It's just something I would do, basically. What you want is to have the sensors capturing the data in the switches, lower switches as well, not just the core switch, for instance. Because you can imagine, let me see if I can show you here. If this PLC is talking to the HMI and it's only hitting the switch, and it's great, we have a sensor there, right? We should have a sensor there, actually, because if we just have this one, then that communication will never reach the core switch. So that's why sometimes you need a lot of different sensors in the lower layers of the network to cover it. That's why it could be costly. And you can also go for R-span if possible. So the remote spanning, so that you don't always need to, have a device basically plugged in, right? So this is one example. Another example is here, and here we have 2 chocolate factories, because, they're not just in Europe, but they're also in Canada, and they produce different types of chocolate. So what you have here is site number 1 and site number 2. Now, it's very nice that we gain visibility into one chocolate factory, right? But you want to correlate that data. You want to see if somebody is attacking my factory in Canada, is this threat actually materializing also in the factory in Europe, right? You want to be able to see that. So what you do essentially is you can have a configuration of the sensors, as we saw already in the lower layers of the network, sending the traffic to the server, and that's the main server basically planted somewhere in the data center in that site. Same thing in the site X, and that's actually being sent to the main server, which is located on the enterprise network or on the plant DMZ. And this way, you can actually gain visibility into different sites. You can correlate that data, and what you can do then, and that's basically the next step, integrate that with your IT. SOC, SIEM, Splunk, right? Because ideally, you want to have the full kill chain. Very often attackers attacking the industrial networks are actually coming through the IT. Phishing, right, or insider threat, and very often, I do that as well, actually. I very often just go from the IT and a lateral movement into the plant network. So you really want to have that sort of information and correlation. Now, we have network visibility. That's great. Now, what do we do with that, right? We went through this whole process of deploying monitoring tooling. But if it's just a tooling, sitting there and you have a GUI that nobody looks at, then it's just a fancy tool, right? That doesn't do anything. You want to get your normal baseline, sort of. So you want to understand what is a normal traffic. And that's why you have to go back to your best buds, operators, right, network engineers, because they know the plant better than you. And you want to ask, okay, is this normal? Is this normal that the engineering workstation sends a file to the PLC every day? I can tell you it's not, because that's usually, it's more static, right? The industrial network, it wouldn't happen so often. You want to understand how the IT communicates with ICS. You want to see if there's any external IP addresses on the industrial network. Spoiler alert, it still happens. Should not happen, because direct communication, it's not aligned with the Purdue model. Not good, right? You want to understand the heavy talkers, the lowest talkers, right? So you just want to get familiar. And usually when we deploy the monitoring tooling, there's going to be a period of, let's say, a month or 2 where the tool is also getting used to the network. But of course, you need to help it, right? You need to actually, accept these alerts or say, this is normal. Maybe this is not. And if we're done with that stage, what we can do then is really look at the baseline deviations. So anomalous behavior. As I said, the patterns. Is the PLC program being changed, every once in a while? Is that okay or not? Known malware. These tools are going to have YARA rules, for instance, right? That basically get the signatures of the known malware, and check if something is happening. I can tell you that in the industrial networks, I very often find configures still. I don't know if you guys know, but this is a thread that was there years back. and that's still sometimes possible to spot that one. You want to look for exfiltration as well, because yes, the availability is the most important, so keeping the production running, right? Not the confidentiality of the data, or the data itself. But what can happen if you have a super secret recipe for a chocolate, right, that you don't want your competitors to get? It could happen that that recipe is gonna be exfiltrated, right, out of your production. Especially that in pharma or semiconductor industry, super important to look for that, right? Is there any data being sent out? So from ICS into the IT and then outside. So that's something we should also keep in mind. Here's an example of how such dashboard or monitoring can look like. This is Clarity, but, every tool, as I said, Nozomi, Dragos is going to do the same thing. What it does, essentially, it layers different, like these are the PLCs, for instance. Here we have regular workstations. Here are the HMIs. It basically recognizes the type of asset we have in the network, and it groups it basically to which Purdue model it should be in. So you can see that level 0, that's the actuator sensors. Level 1, that's going to be the PLCs, and you can actually get this nice visibility. And what it gives you actually, you can immediately say, okay, this PLC is communicating with this workstation, which is actually on level 3, so supervisory area network, right? Is that okay? Or should it go via level 2, right? Maybe it's not okay that we have the direct communication. So things like external assets, external IPs, you can see very easily here on such a diagram. So it's really nice to just see, what's happening in my chocolate factory. And then the next thing is actually getting familiar with the ICS protocols. As I said, many things, and up to this date, every go I go inside, there's usually a protocol I'm not going to know, one of them that I haven't seen yet. You really need to understand, okay, what is happening with those industrial protocols? How do they operate, right? Identify communication patterns so you can recognize whether things are happening in the right way. So like S7COM and S7COM Plus, these are proprietary protocols of Siemens. They have been reversed. S7COM Plus is the new version, so, there's not as much data on it yet. These are used for PLC programming. So exchanging the data between the PLCs as well, diagnostic purposes, right? But the Modbus, it's a field bus protocol. You're going to see it a lot. Modbus is one of the golden standards as well. You're going to see it in every factory. BACnet is for building automation. So, do you have automation in your chocolate factory? If not, maybe, why would it be there, right? You want to understand what's happening. And like OPC, for instance, very often it is based on DCOM, so you know that there's a communication that you want to look into that, right? So it's just the quirks of the protocols that you need to get familiar with. And I'm not even touching upon wireless communication here, because there's a lot of different wireless, like Zigbee, wireless HART, right? These sort of things. There are actually tools to capture this as well. Like Nozomi has this wireless version as well that captures this and sends it back to the main server for logging purposes. But let's not get to this one, because we're going to be here until tomorrow. And this is just to show you, that's just good old Wireshark, of course. This is Modbus traffic. So you can see even when you just capture, Modbus traffic with your computer, when you're plugged into a network, you can see basically information in the packages. Like here you can see that the function code is 1, which is read coils, which is reading coils essentially from the registry. There's also read discrete inputs. So actually function codes can be mapped into what the action is. And that's basically the whole idea of, getting familiar with the protocols. So, now we have visibility. We went through the journey of not having visibility, not knowing what the assets are in our chocolate factory, right? To actually deploying the hardware and the software necessary. We're capturing the data. So now the fun starts actually, right? That's where the journey starts, because now we can start going for threat hunting, for analyzing the alerts, right? We can start training our SOC analysts to actually understand the industrial side of things as well. Or maybe, we make operators into the SOC analysts. I don't know what works better, actually. I haven't figured that one out yet. But definitely there is a long journey ahead. I think I'm really a big fan of integrating things and actually having visibility into both IT and industrial. But that also means system tuning. As I said, just capturing the first, assets, 80% of the assets, let's say, that's just a journey. You probably want to close that gap, right? You want to deploy and make sure that you see everything. And then, then you can go into the proactive hunting. There is, of course, everybody knows MITRE ATT&CK framework. There is also a MITRE ATT&CK framework for ICS. So you can actually map the tactics and techniques of the attackers into that one. So let's say in the case of a chocolate factory, I mean, who would like to hack a chocolate factory? Probably somebody that doesn't like Christmas, right? Because that's the peak operation time for chocolate manufacturers. So then we can look, okay, what would they do, right? Would they bring the production down? And then we can sort of look, okay, what are the techniques and tactics they have? So yeah, that's a little bit of info about the monitoring. I think we could sit here a bit longer if we really want to dive into specifics, but let's leave it for the next time. Thank you very much, and let me know if there are any questions.